So if we go back to the positional audio and we create, I'm actually going to create both the FFT and the waveform at the moment. And if we look at their parameters, there is no value parameter just like there is on the meter. And the reason is that the meter node outputs just a number at every frame, so that's easy to display on the parameter, but the FFT and waveform both outputs an array that can be pretty big. So we can't really read that from parameters. One way to read that though is to write those values to a texture, and then we can read those values. We can read this texture inside a material, and from that material we can do a lot of things. So in order to read that into a texture, we are going to create a cup network. I'm going to rename that again to cup, and there is, in the advanced, there is the audioAnalyser node, and here I can import up to 4 analyzers. I'm only going to import one by one, and then each is going to write to one channel, red, green, blue, or alpha. So I'm going to import the waveform, and I'm going to display that here for now. And on the waveform there is no control right away that I'm going to need, but if I play, you can see that the range values are being displayed. So as opposed to the meter, which only had the max range, so it has the minimum value and maximum value it hasn't counted as it has played, the waveform has the current range, where on the current frame with all those values, what are the min and the max, and also the max range, which is the min and the max that have been accumulated over the whole time it has played. And we can use those to set the range here of how we want to fit the values that we are going to be given by the waveform. But first let's display the texture to see what we have to work with. So if I go back, so I'm going to rename, that's my crowd, I'm going to hide that, and that is the plane with a texture. That's what I'm going to use for now, plane with texture. So I'm going to, instead of displaying this image, I'm going to display the texture of the audioAnalyser. So positional audio, cup, audioAnalyser. So it's not looking great so far, looking a bit strange, but if I play, we can see that there is some value appearing at the top. And maybe the best way to make sense of it is not necessarily to display it as a color, but at least you can see what the texture is. And it's basically divided into two parts, where you have the actual waveform at the top, and at the bottom the speed at which the waveform changes. And we'll look at that again when we talk about the FFT. It's interesting to see how quickly the sound evolves to some sort of beat detection. But again, let's look at it later. Right now, in order to display the waveform, I don't want to just view the texture right away, but I'm going to read the values of the texture and move points up and down on a line, and that should display the waveform as you might be used seeing it in previous audio analyzers. So let me hide or move this around for now, and I'm going to create another geometry. I'm going to hide this, and I'm going to call that waveform for now. I want a line, or I will probably just display hide this helper. So I want a line. I want the line to be horizontal, so I put the axis to the Z direction, and I want a lot of points. 100 for now will do, and I'm going to create a material for it. Material network, rename to mat, and I'm going to create a line basic builder, and I'm going to assign it format line basic builder. Now inside, I can go inside the material, and I'm going to import the texture. So now if I open the material parameter like this one, I will be able to select the texture audioAnalyser, and I want to read the texture so that it moves the points up and down of my line. So in order to read the texture, I need UVs, and I need to check if I do have UVs on the line, and now the only parameter is a position. So in order to replace UVs, I can create an attribute which is going to be based on the point index of every point. And if I look at the attribute create, it has a preset just for that, which is PTY, and it's just an expression which is the point PTNum, the point number, divided by the total number of points. And if we look at the geometry through a spreadsheet, we can see the values of PTI, which is basically going from 0 to 1. So that's going to replace our UVs. Now I just need to import PTY here. So there is also a preset, PTY. And I'm going to convert that float to a vector 2. Float to vector 2. And now I can plug that into the Y position. So I need to convert it from a vector 4 to float, and I need the red channel. The red channel is what we were reading in the audioAnalyser, since we have plugged the waveform audio node into our red channel here. So I'm going to rescale this vector 3 to float, and float to vector 3. I keep the X and Z value, but on the Y value I'm going to use this. So now if I plug this, now if I play and I go closer to the line, we can see the waveform of the sound appearing. But it does not quite look how it really should, for two reasons. One, the range might not be the right one. It looks like it's a bit clamped, and we might not have enough points on our line. So if we go back to the waveform node, you can see that here we have parameters to define how big the texture, how big the amount of information the node is going to give us. So here it's basically giving us an array of 1024 numbers. And if you look at the texture, that is the size of the texture. So let me make sure that our line has that many numbers. So now that's a bit better. The difference is not obvious, but I would like to make sure that the range that we have is the right one. I'm going to put -1 and 2. Yes, now it's not clamped anymore. And I'm going to make that a little bigger. Like this. It's going to be easier to see. So now what I can see on the right is the light. Let me hide those lights for now. And because the line is bigger, I need to make it go higher. I can do that in the shader, so I'm simply going to multiply this. Let's multiply it by 10. And that it is not working. It has disappeared. It's gone way up. Let me put this back to here. So if it's at 0, this is at 0, and if I go back to the let me put this here. It looks like the default value is not at 0, which can bring confusion. So if I go to the waveform and look at the range that we have here, we're basically in a very narrow range between 0.99 and 1, and that is not, I think that's the value that we have now. So I'm just going to untoggle normal range, and the difference between normal range and not normal range is right now we are in decibel, which can be negative values, and normal range tends to convert that into a gain, which is going to be between 0 and 1. But this normal range can sometimes be confusing into which range it will actually convert the decibel range to the gain range. So now what we have is much more obvious. So I'm going to go from -1 to 1. Yes, I know what I'm looking at makes much more sense. And I can even see the sound going from left to right. So that's what I was hoping to display. And now we can see how it is on just one line, but let's use that to affect the size of some instances. So now if we go back to the crowd, and I'm actually going to display the area light and remove the intensity controlled by the meter, so we can always see our group. And I'm going to also remove it here, and let's go into the material that display the instances, and we have quite a few parameters we can play with. One of them is the scale. So for instance, I could place a constant here, and if I make sure that this constant is a vector 3 with some scale, I can affect the scale of those instances, and I can control that scale in the 3 axes. And I could do various things. I can put a noise, for instance, if I use the attribute position as the position of the noise, and I can have each instance have a various scale. So we're going to control the scale with our texture. So if I do the same thing that we had here, in the line, I'm going to create a texture. I'm going to plug that audioAnalyser texture here, and I also need to find out, okay, what are the UVs I'm going to use. But first I will convert that to a vector 4 to float, and I'm going to use the red channel to the instance scale. So I'm going to convert the float to a vector 3, this, and I'm going to plug that here. And if I was to specify a fixed UV where everybody's at 0, 0, then they will all move the same. What I can do though is use the position on that axis, for instance, or maybe from that axis, so it feels like the sound is coming from the screen. On that axis, which I forgot is X or Z, as the UVs. So I'm going to use the instance position again, and vector 3 to float, and now float to vector 2. So let's try with X and see what happens. It's not exactly obvious. I believe they go from here to here, so I would probably need to use the Z. Yes, it does feel like it's going from left to right. What I can do is multiply this by, yes, so we have a sense that the sound is going from one direction, from one side of the crowd to the other. So that's another, the second analyzer. So we've seen the analyzer meter, we've now seen the waveform, and we've seen how to use that in materials to affect many aspects of geometries. And now we're going to see how to use the FFT in a similar way, but we can also use that to control particles, for instance, which can be very exciting.